Pioneer 10. Launched in 1972, Pioneer 10 was the first spacecraft to ever cross the main asteroid belt and the first to perform a close flyby of Jupiter. Its primary mission was planetary science, but its trajectory and speed set it on a path out of the solar system. It became the first human-made object to pass the orbit of Neptune. Pioneer 10's last very weak signal was received on January 23, 2003, after its radioisotope power source dropped too low to reliably run the transmitter. Attached to its antenna is the famous Pioneer plaque, a gold anodized aluminum plate with a pictorial message, including a diagram of a man and woman and our solar system's location, acting as a message in a bottle for any civilization that might one day find it. Pioneer 11. The second of the twin Pioneer probes. Launched in 1973, Pioneer 11 followed its sibling past Jupiter, but then used a gravity assist to become the first spacecraft to ever fly by Saturn, providing humanity's first close-up images of the ringed planet. This maneuver altered its course, sending it on an interstellar trajectory in a different direction from Pioneer 10. Communication was lost in 1995 when it could no longer aim its antenna at Earth. It, too, carries a copy of the Pioneer plaque, and after Saturn it headed outward in the general direction of Sagittarius, toward the center of the galaxy. Voyager 2. Launched just weeks before its twin in 1977, Voyager 2 is arguably the most successful planetary mission in history. It took advantage of a rare planetary alignment to conduct a grand tour, becoming the only spacecraft to ever visit all four of the outer gas giants, Jupiter, Saturn, Uranus, and Neptune. After its flyby of Neptune in 1989, it began its journey outward. In November 2018, its instruments detected a sharp drop in solar wind particles, confirming it had crossed the heliopause, the boundary of the Sun's influence, and entered interstellar space. It is still transmitting data today, carrying with it the golden record, a more ambitious message containing sounds and images selected to portray the diversity of life and culture on Earth. Voyager 1. Though it launched second, Voyager 1 was put on a faster, more direct trajectory. It visited Jupiter and Saturn, but its grand tour was sacrificed for a close flyby of Saturn's giant, hazy moon, Titan. This maneuver bent its path northward, flinging it out of the plane of the solar system at a tremendous speed. In August 2012, it became the first human-made object to ever enter interstellar space. Before it left, it turned its camera back toward home and captured the iconic pale blue dot image, Earth seen as a tiny speck from about 3.7 billion miles, or 6 billion kilometers, away. Like its twin, it carries a golden record and is still actively transmitting data from beyond the Sun's domain, making it the most distant human-made object in existence. New Horizons, the newest member of this exclusive club. Launched in 2006, New Horizons was the fastest spacecraft ever at the time of its launch, designed for a primary mission to perform the first ever flyby of Pluto in 2015. After its spectacular success at Pluto, it continued deeper into the Kuiper Belt, visiting the primordial object Arrokoth. It is now on a trajectory that will eventually carry it out of the solar system, destined to become the fifth interstellar probe. It is still well within the Sun's heliosphere, but is traveling outward at over 30,000 miles per hour. It carries a small container with some of the ashes of Pluto's discoverer, Clyde Tombaugh, making his final resting place the stars themselves. The future. While the first 5 probes are incredible achievements, they will take tens of thousands of years to even approach the nearest stars. A true, dedicated interstellar mission would need to be radically different. The most prominent concept is Breakthrough Starshot, which envisions launching a fleet of tiny, gram-scale nanocraft. These probes would be unfurled as miniature solar sails and then accelerated to 20% the speed of light by an array of powerful Earth-based lasers. At that speed, a flyby of the Alpha Centauri system could take roughly 20 to 30 years, with the goal of returning at least some data, and potentially images, from the target system. Such a mission represents the immense technological leap required to go from being accidental interstellar travelers to purposeful interstellar explorers. Thanks for watching. Do you think humanity will ever reach another star system? Let me know what you think in the comments. Also, please remember to like and subscribe if you enjoyed this video.